London, June 13, 1944. It's 4:18 in the morning. The city sleeps uneasily after years of bombing raids. Then it begins. A sound no one has ever heard before. A rhythmic, mechanical buzzing that seems to come from nowhere and everywhere at once. People rush to their windows, scanning the dark sky. There, silhouetted against the pre-dawn gray, is something that looks like a small aircraft with flames shooting from its tail. It drones overhead like an angry hornet, growing louder, closer, more menacing with each passing second. And then, without warning, the sound stops. Complete silence. For 10 agonizing seconds, Londoners hold their breath, knowing what comes next but powerless to stop it. The explosion, when it comes, shatters the silence and obliterates everything within hundreds of feet. This is the birth of psychological warfare through sound, and it all began with one engineer's calculation error that would accidentally create the most terrifying noise of World War II. To understand how this happened, we need to go back several years and travel to a secret facility on the Baltic coast of Germany. Piedmont. The name would become synonymous with Nazi Germany's most advanced weapons research. While the world knew Hitler was rearming Germany, few suspected the scale and ambition of what was happening in this remote location. Here, some of the brightest minds in German engineering were tasked with creating weapons that would turn the tide of the war. Among them was Fritz Gosslau, a talented but relatively unknown aeronautical engineer who specialized in propulsion systems. Gosslau was not a household name like Wernher von Braun, the charismatic rocket scientist who led much of the missile program. He was a details man, someone who obsessed over calculations, airflow dynamics, and combustion ratios while others dreamed of rockets reaching space. In 1942, Gosslau was assigned to a project that seemed almost pedestrian compared to the V-2 rocket program that was capturing everyone's attention. He was to work on the propulsion system for what was initially called the Fieseler Phi 103, but would become infamous as the V-1 flying bomb. The concept was brutally simple and terrifyingly efficient. Create a pilotless aircraft, pack it with explosives, point it at London, and let it fly until it ran out of fuel and crashed. It was essentially a cruise missile before that term existed, a weapon of terror designed not just to destroy buildings but to break the will of the British people. The challenge was creating a propulsion system that was cheap, reliable, and could be mass-produced by the thousands. Germany's resources were stretched thin across multiple fronts, and there was no room for complexity or expensive components. This is where the pulsejet engine comes into the story. The concept had been around for years but had never found a practical application. Unlike conventional jet engines that burn fuel continuously, a pulsejet operates through a series of rapid explosions. Air enters through shutters at the front, mixes with fuel, ignites, and the resulting explosion forces the shutters closed while pushing exhaust out the back. The pressure drops, the shutters open again, and the cycle repeats approximately 50 times per second. It's mechanically simple, has no moving internal parts beyond the intake shutters, and can be manufactured relatively cheaply. Perfect for a weapon you never intended to recover. Fritz Gosslau was tasked with refining this engine for the V1. He worked obsessively, running calculations late into the night, testing different configurations, adjusting the length of the combustion chamber, the size of the intake valves, the fuel mixture ratios. The engine needed to be powerful enough to propel a bomb weighing nearly 2 tons at speeds of over 400 miles per hour. It needed to be reliable enough to keep running for the 30 to 40 minutes it would take to reach London from launch sites in occupied France. And it needed to be cheap enough to produce in massive quantities. In early 1943, Gosslau believed he had cracked the problem. His calculations showed a combustion chamber length that would provide optimal thrust-to-weight ratio while maintaining structural integrity. He submitted his designs and they were approved for prototype testing. The first test flights were conducted with remote observation, and the results were promising. The engine worked. The flying bomb flew. But there was something unexpected in the data. Every observer noted the sound. That distinctive pulsing buzz that would soon terrorize millions. The pulsejet's rapid-fire combustion cycle created a noise unlike anything heard before in warfare. It wasn't the steady roar of a conventional aircraft engine or the whistle of a falling bomb. It was mechanical, inhuman, relentless. Some described it as a giant motorboat in the sky. Others said it sounded like an enormous wasp. The British would come to call them buzz bombs, or doodlebugs because of this sound. But here's where the story takes its crucial turn. When Gosslau reviewed the acoustic data from the test flights alongside his engineering specifications, he realized something was wrong. The frequency of the pulses didn't match his calculations. The engine was firing approximately 8 to 10 cycles per second faster than his mathematics had predicted. He ran the numbers again. Then again. Each time he found the same discrepancy. There had been an error in his original calculations regarding the resonance characteristics of the combustion chamber. In normal circumstances, this would have been cause for immediate redesign. An engineering error, even a small one, could compromise the entire project. Gosslau was mortified. He prepared a report detailing his mistake and recommending modifications to correct it. But before he submitted it, something made him pause. He looked again at the test flight data. Despite the calculation error, the engine was performing exactly as needed. In fact, it was performing better than expected. The thrust was adequate, the fuel efficiency was acceptable, and most importantly, the reliability was extraordinary. The mistake had accidentally created an engine that was more robust than the original design intended. The higher pulse frequency actually improved fuel mixing and combustion stability. Gosslau found himself in an unusual position. He could report his error, delay production while corrections were made, and risk the displeasure of his superiors in a regime that did not tolerate failure. Or he could say nothing and let the mistake stand. He chose to remain silent. Production proceeded with his original, technically flawed design. And that decision would have consequences that echoed across Europe for the next year. The first V-1 attacks on London began on June 13, 1944, exactly 1 week after D-Day. The timing was deliberate. Hitler hoped these vengeance weapons would demoralize the Allies and disrupt their invasion of France. That first night, only 4 V-1s reached London out of 10 launched. But it was enough. The psychological impact was immediate and profound. Unlike conventional bombing raids, which gave people time to hear air raid sirens and take shelter, the V-1 arrived with minimal warning. You heard that distinctive buzzing sound, looked up, and saw a small winged object with flames shooting from its tail. Then came the moment that defined the terror of these weapons. The engine would cut out. The sudden silence was more frightening than any explosion because everyone knew what it meant. The V-1 was now gliding, falling, about to detonate. You had perhaps 10 seconds. Maybe 15 if you were lucky. People developed an instinctive, visceral response to that sound. Conversations would stop mid-sentence. Workers would freeze at their stations. Children would clutch their parents. Everyone would look up, tracking the sound, trying to judge if this one was going to pass overhead or if the engine would cut out while it was directly above them. It was a form of psychological torture that played out hundreds of times a day. And it was all because of the specific acoustic frequency that Gosslau's miscalculation had created. Had he designed the engine correctly, the pulsejet would have fired at a lower frequency. The sound would have been deeper, less penetrating, less distinctive. It might have blended more into urban background noise. But the higher frequency created by his error produced a sound that carried for miles, that was immediately recognizable, and that seemed to bore directly into people's nervous systems. British intelligence was desperate to understand these new weapons. They recovered crashed V-1s, dissected them, analyzed every component. Engineers were astounded by the simplicity of the design. The pulsejet engine was almost crude in its construction, yet fiendishly effective. They measured the acoustic signature and tried to understand why this particular sound was so psychologically disturbing. What they discovered was that the frequency range of the V-1's engine fell into a peculiar sweet spot in human auditory perception. It was loud enough to be heard from great distances but not so loud that it caused immediate pain. The pulsing rhythm was fast enough to create a continuous buzzing sensation but slow enough that the individual pulses were perceptible, creating an unsettling staccato effect. And the frequency range happened to align with vocal ranges that humans instinctively associate with distress calls. In other words, Gosslau's mistake had accidentally created a weapon that was acoustically optimized to terrify human listeners. It was as if the engine had been deliberately designed to exploit vulnerabilities in human psychology, when in reality it was the result of a calculation error and the decision to ignore it. The V-1 campaign would last for 9 months, from June 1944 until March 1945, when Allied forces overran the last launch sites. During that time, approximately 10,000 V-1 flying bombs were launched at Britain, with about 2,400 reaching London. They killed over 6,000 people and injured more than 17,000. But the psychological casualties were far higher. The constant stress of waiting for that buzzing sound, the terror of the sudden silence, the relief when the explosion was somewhere else, followed by guilt at that relief, knowing someone else had died instead. People developed what we would now recognize as symptoms of post-traumatic stress disorder. Insomnia became epidemic. Some people couldn't leave their homes. Others couldn't stay indoors, feeling trapped without the ability to see the weapon coming. The sound of any motor, any engine, any mechanical buzzing would trigger panic responses. One veteran later recalled that for years after the war, he couldn't use an electric razor because the sound was too similar to a V1. But here's one of the war's bitter ironies. While the V1 created this immense psychological impact, it was actually far less effective as a weapon than conventional bombing raids. The V1 was inaccurate, easy to shoot down once the British developed tactics for intercepting them, and the German resources spent on V-weapons would have been far more effective if devoted to aircraft production or other conventional weapons. Military historians generally agree that the V-weapon programs, including both the V1 and the later V2 rocket, were strategic failures. They absorbed enormous resources, they didn't break British morale as intended, and they didn't prevent the Allied invasion of France. But for the people living under their threat, this strategic analysis was cold comfort. The terror was real. The deaths were real. And that sound, that horrible buzzing followed by silence, was real. Fritz Gosslau survived the war. Unlike many of his colleagues at Piemont, he wasn't recruited by American or Soviet programs afterward. He returned to civilian engineering, working in automotive design, and rarely spoke about his wartime work. There's no record that he ever publicly acknowledged his calculation error or the role it played in creating the V1's distinctive sound. In the decades after the war, as documents were declassified and veterans shared their stories, the psychological impact of the V1 became better understood. Researchers studying the effects of terror weapons and psychological warfare would frequently cite the V1 as a case study in how sound can be weaponized. The distinctive audio signature created by Gosslau's miscalculation became a subject of academic papers, military studies, and historical analyses. Some military theorists argued that the V1 sound should be considered a deliberate design feature, a stroke of genius in psychological warfare. But the truth, as so often in history, was more mundane and more human. It was an accident. A mistake in calculations that went uncorrected because an engineer was afraid to admit his error, and because the mistake happened to work well enough in practice. This raises uncomfortable questions about the nature of technological warfare and human responsibility. If Gosslau had corrected his error, would the V1 have been less psychologically damaging? Almost certainly. The sound was the weapon's most terrifying aspect. Would fewer people have died? Possibly, though the explosive payload would have remained the same. Would it have changed the course of the war? Almost certainly not. The V1 campaign failed to achieve its strategic objectives regardless of how frightening the weapons sounded. But for the individuals who lived through those 9 months of terror, these historical what-ifs are beside the point. The V1 flying bomb, with its accidentally optimized terror-inducing sound, became one of the defining experiences of the London home front during World War II. Survivors passed down stories to their children and grandchildren. The sound became embedded in British cultural memory. Even now, 80 years later, there are recordings of V1 engines that make elderly listeners instinctively tense, their bodies remembering the fear even if their minds struggle with the memories. In London, there are still buildings with V1 damage, still empty lots where reconstruction never quite filled in the gaps. Physical and psychological scars that trace back to one engineer's calculation error and his decision to let it stand. The story of Fritz Gosslau and the V1 sound reminds us that history often turns on small moments, human decisions, and unintended consequences. Grand strategies and brilliant inventions matter, certainly. But so do mistakes, miscalculations, and the very human desire to avoid admitting when we've gotten something wrong. Sometimes these small human failures create ripples that spread far beyond what anyone could have imagined. In warfare, we often focus on the bombs, the bullets, the explosions. But the V1 teaches us something different. Sometimes the most effective weapon isn't the one that causes the most physical destruction. Sometimes it's the one that gets inside people's heads, that makes them live in constant fear, that turns everyday sounds into triggers for panic. And sometimes that weapon is created not through brilliant psychological insight but through a mathematical error and a moment of human weakness. The V1 flying bomb killed thousands and terrorized millions. But perhaps its most lasting legacy is this reminder that in war, as in all human endeavors, we often don't fully understand the consequences of our creations until it's far too late. Fritz Gosslau designed an engine. His mistake created a nightmare. And the sound of that nightmare still echoes through history, a buzzing reminder of what happens when human ingenuity, human error, and human cruelty combine in the crucible of total war. There's a deeper layer to this story that deserves our attention. After the war ended, Allied intelligence teams combed through what remained of German research facilities. At Piemont, among thousands of documents that survived the final chaotic days of the Reich, they found Gosslau's original notebooks. Page after page of meticulous calculations, design sketches, and test data. And there, buried in the technical details, was something remarkable. Gosslau had known about his error almost from the beginning. Not just known but documented it. His notebooks contained a complete analysis of the discrepancy between his calculated pulse frequency and the actual performance of the engine. What the investigators found was even more intriguing. Gosslau hadn't just noticed the error and moved on. He had conducted an extensive study of why the engine worked despite his miscalculation. He had tested the acoustic properties. He had measured the psychological responses of personnel at the testing grounds who were exposed to the sound during engine tests. There were notes about how workers would visibly tense when the engine fired up, how some requested transfers away from the testing area because they couldn't tolerate the noise. Fritz Gosslau knew. He understood that his mistake had created something uniquely disturbing, and he had chosen to weaponize that knowledge rather than correct it. This revelation changes the narrative fundamentally. It wasn't simply an engineer too afraid to admit an error. It was a conscious decision to transform an accident into a tool of psychological warfare. The question that haunts historians who have studied these documents is simple but profound. At what moment did Gosslau cross the line from engineer to architect of terror? In interrogations conducted in 1946, Gosslau was questioned about his work on the V1. The transcripts make for uncomfortable reading. He showed no remorse, no second thoughts about the psychological damage his engine had caused. Instead, he spoke with a kind of clinical detachment about acoustic frequencies and psychological response curves. When asked directly if he felt any responsibility for the terror the V1 sound had created, his response was chilling. He said that sound was simply physics, that human responses to frequencies were predictable phenomena, and that he had merely optimized an engine design. The deaths, the fear, the trauma, in his view, these were the results of war itself, not his engineering choices. This raises questions that extend far beyond one weapon in one war. In our modern age, where technology advances faster than our ethical frameworks can keep pace, where algorithms can manipulate emotions and surveillance systems can predict behavior, the story of Fritz Gosslau feels uncomfortably relevant. How do we hold creators accountable for the unintended consequences of their creations? Or worse, for consequences they understood but chose to ignore or exploit? The V1 sound also had unexpected effects on the people launching them. German soldiers stationed at the launch sites in France reported their own psychological difficulties with the weapons. Unlike bomber crews who could distance themselves from their targets, the V1 operators heard that same terrifying sound day after day. They watched the flying bombs disappear into the distance, knowing that buzz would soon go silent over London, over Antwerp, over other cities filled with civilians. Some soldiers requested transfers. Others began to show signs of what we would now recognize as moral injury, the psychological damage that comes from participating in actions that violate one's own ethical code. There are accounts of launch crews who deliberately sabotaged V1s, making subtle adjustments that would cause the weapons to crash into the English Channel rather than reach their targets. The sound of the weapon they were launching became a constant reminder of what they were doing, an auditory accusation that followed them through their days. British defenders faced their own complicated relationship with that sound. Fighter pilots developed specialized tactics for intercepting V1s. They would fly alongside the buzzing bombs, carefully position their wing tip under the V1's wing, and then flip it, sending the flying bomb into an uncontrolled spin that would crash it into empty fields or the sea. These pilots became intimately familiar with the sound. They could judge the V1's speed and altitude by subtle variations in the pulse frequency. That terrifying buzz became their hunting signal, the sound they flew toward rather than away from. One pilot, Flight Lieutenant Ken Collier, described the strange intimacy of flying next to a V1. He said you could hear the individual pulses of the engine even over the roar of your own aircraft. You could feel them somehow, a vibration in the air that made your teeth ache. And there was always the knowledge that inside that ugly metal tube was nearly a ton of explosives, that any mistake in the interception could mean your own death. Yet these pilots went up day after day, chasing that sound across the skies of southern England. The sound even affected how the war was reported. Radio correspondents trying to describe the V1 attacks to listeners in America and other countries struggled to convey what the weapons sounded like. How do you describe a sound that has no precedent? They compared it to motorcycles, to chainsaws, to mechanical heartbeats. Some recordings were made and broadcast, but listeners who hadn't experienced the V1 attacks in person couldn't fully grasp the visceral impact of that sound when you knew it carried death. Winston Churchill, in his memoirs, wrote about the V1 campaign with unusual emotional intensity. He described the sound as something that got under your skin, that made even the bravest people flinch. He noted that conventional bombing raids, as terrible as they were, at least felt like combat, like a fight between opposing forces. The V1 felt different, more impersonal, more mechanical, more inevitably cruel. Just a machine buzzing mindlessly toward its target, incapable of mercy or discrimination.